Exercise 2.27. The points A, B, etc. are joints of the hexagonal structural element. Let RAB be the position vector from joint A to joint B, RAC the position vector from joint A to joint C, and so forth. Determine the components of the vectors RAC and RAF. Well, analyzing the figure that we have right here, we can be sure that an hexagonal shape has six faces. So 1, 2, 3, 4, 5, and 6. Now, because of these two, I already know that every single one of them is going to be 2 meters between the one that follows as well. Now, if I divide these by 6 different pieces, I'll have the center right here. Now, I'm going to do it, but showing it to you. Right here I have the center, and I can be sure that if I divide 360 degrees, which is the entire circumference, by 1, 2, 3, 4, 5, and 6, I'll have 60 degrees in every single one of them, you know? Now, because of that, I can be sure that from here to here I have 2 meters, but as well I have 2 meters from here to here. So that means that I'm going to have 60 degrees right here, 60 degrees right here, and 60 degrees right here. 2 meters right here and 2 meters right here. Now, they're asking for the vector RAC. Remember, AC means from A to C. If it were, for example, CA, that means that the direction would change towards this. Remember, for when we're talking about a vector, we care about the magnitude and the direction. Now, this should be, sorry, right. We have as well to find this vector, which is the vector AF. Now we have AF and AC. Alright, so I'm going to create one triangle right here, but I want to do it, for example, here. Right here I have AF, and this point I'm going to call it, for example, K. I'm going to erase this because this is not straight. So this could be confusing for some of you. Now we have A, F, and K. Right here I have 90 degrees, and right here I have 30. Why do we have 30? Because right here I have 60, and right here I have 90. 90 minus 60 is equal to 30. Because of this, remember that the symmetry of the angles within a triangle is always equal to 180 degrees. That means that right here I have 60 degrees. So I only know the magnitude of AF, which is 2. Remember, right here I have 2 meters. Now I can use the sine law for me to find the other 2 components. So 2 divided by the sine of 90 is going to be equal to Ka divided by the sine of 30. This is equal to Fk divided by the sine of 60. For when you are doing the sine's law, all you have to take into account is the opposite angle. For example, for this magnitude, the opposite angle would be this one. For this magnitude, the opposite angle is this one, and so forth. Right? That is how you can create these equivalences. Now, because of this, I can say that 2 divided by the sine of 90 multiplied by the sine of 30 is equal to Ka, and the same thing multiplied by the sine of 60 is equal to Fk. Now, this is equal to, you have to be aware of this d. You have to be sure that you are working in degrees, because we are working in degrees. If you don't have this, you should change it, because you'll have a wrong result at the end. Now, 2 divided by the cosine, sorry, by the sine of 90 multiplied by the sine of 30 is equal to 1, and multiplied by the sine of 60 is equal to the square root of 3. Alright, so we already know that this is the square root of 3 and this is equal to 1. Now, the one for the vector f, for the vector RAF is going to be negative, -1 along the I direction, plus the square root of 3 along the J direction, and right here we have our first answer. Why is it negative? Because of the direction of the component. Right here we have the vector that we need. It is divided by 2 components, this one and this one. That means that this component is pointing towards the other direction for the positive numbers. That means that this is negative. This is positive because it is pointing towards the same direction. Right? Right here we have our first answer. Second answer is pretty much the same, because we already know that the y component, it's going to be the same one, as well positive. So all we have to do is to look for this component. Now, I'm going to create the triangle that we have right there. This is B, this is A, this is C, and this I'm going to call it, for example, T. Now, I already know that this is equal to 2. Oh, no, this is not equal to 2. This I don't know yet. This is equal to 2 and this is equal to 2. Right here I have an angle of 90 degrees. Right here I have an angle of 30 degrees because of the same reason that we have done, or that I've explained right here. And because of that, everything should be equal to 180. Right here I have a 60 degrees angle. Because of this 60, I'm able to find this other part, because this would be equal to 180 minus 60, 120. And all I have to find is this part and this part, because I already know this. Okay, this I don't need it because I already did it. So all I have to find is BT. So BT is going to be equal to 2 divided by sine of 90 multiplied by the sine of 30. You know, because of the same reason we did here. And we already did that. This should be equal to 1. Yep, So pt is equal to 1. That means that this dimension is equal to 3 because of this is equal to 1. And this we already know that is equal to the square root of 3. So that means that the vector RAC is going to be equal to 3 plus the square root of 3. Because of the same reason, remember, if we have our vector pointing towards this direction, I can have this component and this component. Both of them are positive because of the direction that are pointing. And that would be all, guys. This is how you can solve this exercise.